Okay, good evening everyone, and welcome to Weeks in the North meetup. Woo! So Weeks have been in the North for almost a year now, and we had two meetups, and this is the third one. On first we hosted WeWork, and they hosted us. On the second we hosted GitHub, and on this one we're gonna host Outbrain. So welcome everybody, Vlad. He's a team lead in Outbrain, and he's going to tell us about Nest.js on the second hour. Yeah, so speaking of Outbrain, I'd like to thank Outbrain for participating in this meetup and taking part in building a strong dev community in the North. I'd also like to thank WeWork for providing this amazing place and taking care of us day and night. Who I am? My name is Jenia, and I'm 30. I'm a senior engineer here at Wix. I've been working here from basically day one of Wix Haifa. Apparently I have a lot of free time, so I do open source, and I write blog posts, and I play guitar and play drums, and do kite surfing. So it's not a surprise that my team do not believe that I have a family. But I do have a family. I have a beautiful wife and a son, and I took a picture of my family to prove them wrong. Okay? So I know you're gonna say it's not you, it's Family Guy, but I am a Family Guy, guys. Okay? So hopefully all of you have seen the title of our first talk, and the title was focusing on A and E in chromatic scale. Obviously, it's a tech meetup, so we're not going to talk about music. What we are going to talk about is about developing Chrome extension with Angular. But before we dive into the code, we need to answer one simple question. Why would anyone in the world want to develop Chrome extension? So there are basically a few use cases for this. The most obvious one and the less probable one is profit. Yes, there are developers who sell their extensions or earn money from paid subscription, something like that, but most of the extensions are for free. So the most probable use case for you guys, as it for me, is an extension for your developer needs. And we have a few examples in Wix. Here we have a handful of such extensions developed in-house, and I'm going to present you a couple of them. So I'll present you the two I use the most during my day-to-day work. So this is a back office of Wix dashboard, and we have a lot of artifacts here downloaded from CDN, and each of such artifacts can have a different version. So first extension for our convenience is static overrides, and it allows us to override the version of specific artifact we're using. I can override this whole dashboard version, or I can override specific widget version, or even if I want to develop a widget, I can change it to local. So basically, most of my time I develop in production in a real Wix site with some static override to specific local widget that I develop. Another good example for a useful extension for development is Petri Sidekick, we call it. So here at Wix we have a lot of A/B tests and ABC tests running. So the Wix site you see, it's not the same Wix site you see. And for us, for developers, it's very helpful because in this way we can gradually roll out features to the users. So eventually, for each such A/B test, or for each such experiment, we have an actual if in the code that tells, okay, if this experiment is enabled, then run this code, otherwise run this code. So for example, you can see this widget, it's with experiment enabled, and now when I disable the experiment, we'll see some other widget. Okay, so this is how extensions make our life easier. Cool. Okay, so how it's gonna happen today? We're gonna start from scratch, from literally nothing, empty console, and we're gonna finish with a fully functional Chrome extension. When I say from scratch, I mean we start with ng new. Since it's taking time, I'm gonna run it now. And we're going to talk a bit about Chrome extension. What a Chrome extension consists of. So first player in the field is background script. Background script in Chrome extension is the part of Chrome extension that listens to browser events such as web navigation or a new tab opened or tab moved or your extension has been updated. All kinds of browser events. Next one is content script, and content script is the one who runs in the context of a web page you're on and has access to the actual DOM. It can read the DOM, it can write to the DOM. This is what changes the view of the web page if you need. The third one is pop-up HTML. When we go back, when we go back here and we press on one of the extensions, there is a pop-up opened. This pop-up actually has its own HTML and its own JavaScript, and we're going to focus mostly on this part today. Well, honestly, we're going to focus a lot on the process and the environment setup, and this part is going to be really small, but this is where you incorporate Angular, because this is the only visual part of the extension. And it's demo time. Yeah, let's see. Okay, so now we have a brand new project, Angular project, just dummy app generated by Angular CLI. And let me open it in VS Code. The entry point, okay, the entry point of Chrome extension is its manifest. It's file that defines version, description, all kinds of actions in the extension, permissions, and so on. So, we're going to run ng-build. And when ng-build is run, it puts all the artifacts in dist folder. We're going to use this dist folder as a source folder for our extension. So, in order for our extension to be an actual extension, we need a manifest to be present in this dist folder, which is not at first. So let's create one. Now we have manifest. This is the manifest. You can see that the name of extension, great extension, version, manifest version is always 2. And now we need it to be in the dist folder. For that, we're going to add it to assets in Angular JSON. Okay, now we're going to run the build again. And let's just make sure that we have this manifest inside this folder. Okay. And we have it. Okay. Now, how do you load Chrome extension into the browser? For that, you have to go to Chrome extensions and enable developer mode. Once developer mode is enabled, you have a few options here: load and pack extension and update. We're going to use this one to load unpacked extension from our folder. And failed to load extension. Manifest is not a valid JSON. Okay. That's correct. Let's run it again. Okay, so we have an extension. Here it is. Yeah, but it basically even doesn't show anything. So every extension that appears here has a browser action or a page action. This button here is, it can be browser action or page action. So we're going to define one. We're going to define a browser action, which will let the browser know that the default pop-up for our extension is the index.html of dummy app. So here we define browser action, default pop-up. We're going to build it again. And reload the extension. The extension is reloaded. And now something has changed, okay? What has changed? We have error, okay? How do we investigate error in Chrome extension? We have a few options. First one, we can look here. We have an error. It's not very readable, so let's explore the second option. Second option is this white rectangle is just the index.html that failed to load. So we can just inspect it just like regular HTML. And here we can read the error. Refuse to evaluate a string as JavaScript because unsafe evil is not an allowed source of script in the following content security policy directive. And we can see that it comes from JIT compiler, just-in-time compiler. So who can guess what happened here and why it doesn't work? Okay. The error says refuse to evaluate a string as JavaScript because unsafe evil is not an allowed source of script in the following content security policy directive, script SRC. So basically the issue here is that by default, Chrome extensions disallow to evaluate JavaScript at runtime. And well, guess what? JIT compiler, this is exactly what it does. It evaluates JavaScript at runtime. So we have a few options here to solve this problem. The first option is just change the security policy and allow JavaScript to be evaluated in the Chrome extension, but I would strongly advise against that. And why? This is why. Okay? And another option is to actually tell Angular to not evaluate code at runtime by changing ahead of time compilation from false to true. So, here we go. ng-build. Let's clear out the errors. Reload the extension. And here we go. This is the dummy app inside our pop-up. Now, when we develop a regular Angular application, we have ng-serve that runs for us developer server and communicates with the browser to reload the changes once there has been a change in the source code. Ideally, we would want the same for our extension, but unfortunately, that's not the case. We cannot use it, and this is because dev server in Angular loads all the assets into the memory, and for this Chrome extension, we need an actual physical folder on the disk. So we cannot use ng-serve, but what we can use is build watch. When you run ng-build with watch flag, it's gonna do just the same as dev server, but it's gonna place the assets in the disk folder. So if we run npm start now, we run ng-build ---- watch, and it's going to watch all our assets. It includes source code, it includes assets. So if I change manifest, you can see it rebuild. And if I change the source code, obviously it is being rebuilt. Now, to apply the changes from manifest, we still have to reload the extension because manifest is an entry point for the extension, and there is no other trigger apart from reloading the extension to update the manifest. But for the pop-up, for the HTML, the trigger is actually opening the pop-up. So when we open the pop-up, browser reads it from the dist folder. So if we change now, running with build watch, if we change the extension, HTML or source code, then it's enough just to open it again and we'll see the change. Okay? We're going to talk about background script live reload a bit later. And for now, we have this beautiful extension, which basically does nothing. So we want it to do something. Let's first define what we want it to do. Most of the extensions are active on certain circumstances, and we're going to enable our extension only on sites under Google.com domain. Then we'll put a color picker inside this extension, and we will add a button, and we will change background color of a page we're on with to the selected color when we press on this button. Okay? Cool. Demo time again. So, up until now, we used browser action, and browser action is enabled by default for every site. We want this, just let me remind you, this is browser action. Okay, this button can be either browser action or page action. Basically, the only difference between the two is that browser action is enabled by default for all the sites, and page action is disabled by default for all the sites, and we enable it in background script. So first thing, we're going to change the browser action to page action. Code recompiled. We can reload it now because we changed the manifest, and you can see that the extension is disabled. Now, in order to enable it, we would want to listen to browser navigation event, match it against google.com domain, and if there is a match, we would want to enable this page action. So let's create a browser script. Browser script created, and now when we run the build, we will notice that the browser script is not part of the build. Why is that? This is because no one actually imports it, so it just hangs in the air and it isn't compiled. We cannot import it from main TS or to include it in a script section in AngularJSON for one simple reason. The background script, if we import it from the main TS or in some context of scripts, it will be loaded in context of pop-up HTML. Remember, the index HTML of this great extension is actually the HTML of the pop-up. And we don't want to run the background script logic every time we open the pop-up. What we can do is adding background script as a separate entry in the build. And for this, we're going to need to modify the build that runs under the hood in Angular. Angular uses Webpack for building its assets. To modify it, we're going to need to do a few changes. First thing, we're going to need to install custom Webpack builder. Next one, we're gonna need to define a new config for Webpack. And define a separate entry for background script. So here we go. Now when we have this custom configuration and custom builder, we need to change the builder in AngularJSON. So it's gonna be Angular builders, custom Webpack browser, and we need to point it to our configuration. Okay, this is it, I think. Let's see if it builds. Okay, we have a background compiled. Woohoo! And now let's fill it with some content. Obviously, it's not going to compile because we don't have the types installed, so let's install them. These are the types for Chroma API. We also need to add them into tsconfig types array. Okay. Now it recognizes the types and we're good. So let's see what happens here. When our extension is installed, we start to listen to web navigation completed event. And then if there is a match between the Google.com domain and URL of web navigation event, we're going to query the open tabs, we're going to choose the active one, and we're going to show our page action. Now the only thing that's left is to add into manifest our background script. We need a few permissions. We need a permission for active tab and for web navigation. And this is the background script, just an entry here. Cool. npm start. We changed the manifest, so we have to reload the extension. And now we see that there is a background script because we see this little guy here, inspect views background page. And let's try to navigate to google.com. Didn't work. Cool. I anticipated that. Background page. Let's see here. We can see that our background script is being loaded, but it's not being executed. Why is that? Let's look at the background script. Background script here, we can see our code. It's fine, it is included here, but it's wrapped with some weird function and webpack JSONP array, stuff like that. Anybody knows what does it mean? So basically, that's the mechanism of webpack chunks to be loaded. We have a few chunks, even in regular Angular application. You have basically, when you just compile it, you have main, you have polyfills, runtime, styles, and vendor. And those chunks can be loaded to the browser without specific order. What takes care of that is runtime.js. There is a code that Webpack injects on the browser window and takes care of loading the chunks. So this runtime.js is loaded in the context of pop-up HTML, but it's not loaded in background script. Remember that background script runs in a separate context. So all we have to do here is to add runtime.js. It can be just the same runtime.js because it's just the same code every time Webpack injects. Now we did loaded. Let's reload and let's go to google.com. Woohoo! Cool. Now, another important part is background script live reload. So we already have this button for manifest, and we can reopen our pop-up to load the changes for the source code. But background script is much more. Let's say we would want it to be as easy to reload as pop-up, but we don't want to reload it every time to reload the whole extension, because background script changes a lot, unlike manifest. So for this, we also have a solution, and this solution called, let me see, Webpack Extension Reloader. So since we already have a custom Webpack configuration, we can add Webpack Extension Reloader plugin, which will take care of reloading the background script once there was a change to background chunk. Let's install it. Now, We're not going to need it in production because the way it works, it injects some code into background script and creates a session against Webpack build in watch mode and browser. And it works just like dev server for Angular, just for Webpack. So we're not going to need it in production because obviously we don't want this code to be executed in production. Let's create a separate Webpack configuration for development build. And this dev config will make use of our product config. And apply the extension reloader. You see, here we require our custom Webpack config. We spread it here, and we apply extension reloader. We tell it reload the page when the entry background has been changed. Okay. Now, a few more things. We have to add dev configuration. Here to let Angular know that it should use different configuration, different custom Webpack config when we run it in dev mode. And the second thing, we're going to actually run it with this configuration. Whoops. I didn't save it. That's right. So you can see starting the hot extension reload server, it means that it actually works. And now we don't need to reload the extension every time we change the background script. Although now for the first time, we do need to reload it because the background script that currently loaded into extension does not contain this wrapper code. So we reload it. Let's go to google.com. We can see it working. Now let's change background script to google1.com. It's being recompiled. And let's navigate to google.com again. And it doesn't work because we changed the match pattern. Let's change it back. So now we have a live reload for a pop-up by reopening the pop-up, for background script by just changing the background script, and for manifest, well, we have to reload the extension. But still our extension does nothing. We came to the point that it is active only under google.com domain, and now we would actually want it to do something. And given the whole setup here, it should be a piece of cake. So let's add a color picker. We're using Angular, so we can take advantage of all the Angular ecosystem. So we're going to use ngx color picker library. We're going to import its module in app component. Woo-hoo. Import color picker module from ngx color picker. Let's add it to imports of our app module, color picker module. Let's add here a color property and replace this dummy code with color picker code. So I'm not gonna go with you over all these properties. You can check out yourself on the official page of NGX Color Picker. But basically, it's just renders color picker to the HTML page. Did I miss something? Let's see. Okay, probably I missed something. Oh no, there is a color picker. We have a color picker, but it does nothing yet. So, to make it do something, we have to run inline content script. So let's add a colorize method to our extension. Here, just to explain what happens here, we query the open tabs again, and we look for active tab, and then we execute a simple inline script on this tab, and the code of the script is just document body style background change to this color property. All that left is to bind the colorize method. Oh, come on. Okay. Okay, we only have one small thing left to make the whole picture. Currently, when we open the extension and choose a color and then close the pop-up again, reopen it, the color is being reset. We're going to use Chrome Storage API to save the color and load it on extension on app component ng-init. So let's add this here and update color method. So when we update the color, in a minute we're going to bind it to color picker callback. We save the color into Chrome storage, and when the component is initialized, we're going to read it from the storage and set this property. Okay. Update color, color picker change, update color. Oh, and one more thing. Now, when we use storage API, we have to add a permission to storage. Cool. So we changed the manifest. We have to reload the extension. Let's navigate to google.com. Open, close, reopen, and it's saved. And we apply the color and the background changes. This is it. We have an extension working. You can find the source code on GitHub. If you want to dive in and you forgot something, you can read the blog post on Medium. And thank you.